Today on Applied Science, I want to talk about passing gas from one cylinder to another. So the problem is this cylinder is full of ethylene, but it's a rental, so I have to return it. And I want to transfer the ethylene to this cylinder, which is empty, that I own. So let me show you the setup. I have the full cylinder connected to the empty cylinder with this high pressure copper line. And then there's a T and a valve and a vacuum line that runs down to the vacuum gauge and this vacuum pump here. So we're currently at about 340 millitorr, and the purpose of that was just to get the remaining gas out of the empty cylinder and also to remove the air in the line between the two cylinders. So this way I'll have a very clean transfer and I won't have to worry about contaminating the gas. This is only 99.5% pure gas anyway, so it's not like I have to get every last molecule out. I also have the receiving cylinder in this water bath that's chilled to about 7-point-something degrees C. And the purpose of that is to get the ethylene to turn into a liquid in the receiving cylinder and pull more gas out. So ethylene is normally supercritical at room temperatures and at the pressures that are inside these cylinders. So if I were to just connect the two cylinders together at room temperature and open both valves, I could save about half the gas. You know, the pressures would equalize, the volumes are about the same, and I would end up with half. But since I want to save as much gas as possible, if I cool this down and cause the ethylene to condense in here, it will lower the pressure in the system and we'll get more gas to transfer. The temperature in the receiving cylinder is below the critical temperature, so we should get real liquid to form there. I also have the full cylinder on a scale so that we can measure how much mass has actually been transferred. This should have held about 5 pounds of ethylene when it was full, and I've used a very small amount so far. Okay, so I'm going to close the valve here, which will isolate the vacuum system from the transfer, and I'm going to turn off the vacuum pump just so we can hear if there's any sort of slushing or whatever noise this is going to make when we transfer. And now I'm going to open this valve as slowly as I can. The fitting here is getting quite cold, and you can see there's frost forming on the copper piping. We've transferred about 2.5 pounds of gas, and what's interesting is that the cooling water temperature has risen to about 8.9 degrees C, and the critical temperature is 9.2. So very likely the temperature of the gas inside the receiving cylinder is still supercritical. So we have to wait a while for my cooling water system to lower the temperature further, and we'll see if we get more mass transfer as the gas liquefies in the receiving cylinder. After waiting for the receiving cylinder to cool down some more, we've still only transferred about 2.6 pounds of gas, and so I added a gauge here to help figure out what's going on. And the gauge shows that we're definitely below 50 bar, which means that there's no supercritical ethylene anywhere in the system. It's got to be entirely gas here and gas-liquid mix in the receiving cylinder. And I even used a heat gun to make sure that the starting cylinder is over 10 degrees C, so there's no liquid in here at all. So either they underfilled me, or I used more gas than I thought, or there's a problem with the scale, or a combination of all these things. But I think I've transferred all the gas that I can, so I'm going to give this cylinder back now. Okay, see you next time. Bye.